Alpha Centauri b, K-dwarf. If Alpha Centauri b were to replace our sun, there'd be a 50% decrease in brightness. However, your eyes wouldn't notice that much of a change. Because human eyes are very good at adjusting to light, a 50% drop in brightness wouldn't plunge us into darkness. It would just look like a slightly hazy late afternoon day. Its light would also be slightly more orange. And if you looked at it directly, since you take less damage than with our current sun, you'd notice that it looks slightly smaller. What you would notice more than anything, though, is the temperature change. At our current distance, receiving only half the solar energy we're used to would be an instant, apocalyptic extinction event. Within weeks, global temperatures would crash to around minus 70 degrees Fahrenheit. The oceans would freeze over, and continents would be buried in snow. This would trigger a deadly, runaway ice albedo effect. All that bright white ice would reflect the star's remaining faint light back into space, accelerating the deep freeze in a feedback loop. To make matters worse, Alpha Centauri b has only about 90% of our sun's mass. With less gravity holding us in our current orbit, Earth's existing momentum would carry it farther out, widening the orbit and dropping temperatures even more. In this scenario, agriculture would simply cease to exist. Earth's surface would become a frozen, lifeless wasteland. The only remnants of humanity would be the lucky few who managed to retreat into deep underground bunkers, surviving entirely on geothermal and nuclear power. But what if we fix that? Take the second setup. We magically move Earth closer to the star, placing us safely back inside the habitable zone. The apocalyptic deep freeze is avoided, but our problems are far from over. First, because we'd be closer to a star with slightly less mass, orbital physics would demand that Earth move much faster to stay in orbit. Our 365-day year would instantly shrink to about 225 days. This would throw the planet into chaos. Seasons would cycle roughly 40% faster, meaning farmers would suddenly face drastically shortened growing periods. Winter would arrive months earlier than anyone was ready for, devastating global food supplies. Even if we managed to adapt our calendars, plants would be thoroughly confused. Alpha Centauri b is cooler than our sun, meaning its light shifts away from blue wavelengths and toward the red and infrared parts of the spectrum. Earth's crops evolved under our sun's particular light, so yields would plummet until we could genetically engineer food to thrive under an orange sky. Finally, Alpha Centauri b is highly magnetically active. It frequently blasts out high-energy X-rays and solar flares. So while humanity is desperately trying to farm under a fast-forwarded, orange-tinted sky, we'd also be dealing with intense geomagnetic storms, regularly frying satellites, disrupting radio links, and stressing electrical grids. We wouldn't freeze to death like in the first scenario, but surviving would require completely reinventing how we live. Procyon A, F-type. Procyon A is a brilliant, searing hot F-type star that pumps out roughly 7 times more light and energy than our sun. If Earth stayed at its current distance, the sky would turn a blinding, brilliant white, and the global average temperature would skyrocket to nearly 300 degrees Fahrenheit. The oceans would literally boil, and as water flashed into steam, the atmosphere would trigger a catastrophic runaway greenhouse effect, trapping all that new heat and turning Earth into a super-pressurized, Venus-like hellscape within weeks. Even if you could survive the heat, the light itself would be lethal. Procyon A burns much hotter than our sun, meaning it blasts out massive amounts of UV radiation. This would instantly shred Earth's ozone layer, permanently blinding wildlife and causing catastrophic cellular damage to anything exposed to the daylight. To survive a star this bright, we would have to magically move Earth much more outward, placing us roughly halfway through our current asteroid belt. At this distance, the temperature would finally stabilize, but life on this new Earth would feel completely alien. First, the daylight would have a harsh, cold, brilliant white tone compared to the warm yellow of our old sun. Second, the calendar would be completely destroyed. The new Earth would have a much wider path to travel. A single year would now last roughly 1,300 days. Because Earth's tilt remains the same, each season would last for 10 to 11 months. Winter would no longer be a season. It would be a year-long endurance test. Human civilization would have to completely restructure global agriculture to stockpile enough food to survive these brutal, super winters. However, we haven't yet touched where the real chaos comes from: the night sky. Procyon isn't just one star, it's a binary system. Orbiting Procyon A is a dead, dense white dwarf known as Procyon B. This white dwarf has a highly elliptical orbit that would occasionally bring it terrifyingly close to Earth's new position. During its closest approaches, Procyon B would appear in our night sky as a piercing, brilliant pinpoint of light, up to 5 times brighter than our full moon. Because it is a sharp point of light rather than a glowing disk, it would cast harsh, eerie shadows across the landscape. Worse than its light is its gravity. Procyon B is incredibly dense, and as it swings passed, its gravity would violently tug on Earth. Every few decades, our orbit would be stretched and warped, causing erratic, extreme climate swings that would plunge the planet into sudden ice ages, followed by intense hothouse periods. To top it all off, all of our adjustments would be just a temporary fix. Procyon A is reaching the end of its stable hydrogen-burning phase. It is currently swelling into a subgiant. In the future, its heat output will aggressively expand, meaning the habitable zone won't stay put. Even at the new distance, Earth's oceans would eventually begin to boil all over again, forcing humanity to find a way to continuously move the planet further and further into the dark just to survive. Kepler-16, Circumbinary. If the Kepler-16 binary system replaced our sun, the very first sunrise would be a masterpiece. You wouldn't see one disk climbing the horizon, but two, a small orange sun and a dim red bead. As they rose, the shadows of trees and buildings would split into two distinct forks that slowly slide apart throughout the day. Unluckily though, you wouldn't have much time to admire the view. Kepler-16a and 16b are both small, dim stars, and together, they put out only about 15.5% of the light of our current sun. At our current distance, it would trigger a planetary apocalypse. Global temperatures would violently crash to nearly minus 135 degrees Fahrenheit. The oceans would freeze solid, the water cycle would completely halt, and Earth would become a dead, frozen ice ball in a matter of months. This time, to keep Earth warm, we would have to move it to roughly the distance of Mercury. Here, something unique happens. Not only does an Earth year shrink to just 94 days, but there's a second calendar at play. The two suns orbit each other every 41 days. Because the stars constantly shift closer and further apart, the total amount of light hitting Earth pulses on a 41-day rhythm. Plants would be completely confused, with their photosynthesis driven by this weird, repeating mini-season layered on top of the year. Animals that navigate by the sun would lose their minds trying to track two separate stars that constantly change distance from one another. Then come the eclipses. Every few weeks, one star crosses in front of the other. You'd be walking outside, and the daylight would noticeably dip for about 6 hours. Sunsets would be equally surreal. Because the stars can drift apart in the sky, you would experience a double sunset. The orange star might set first, leaving the world in a strange, red-tinted twilight for an hour or two before the red dwarf finally dips below the horizon. There's a risk, though. In astrophysics, a planet orbiting two stars must stay far enough away to avoid their chaotic gravitational tug-of-war. For the Kepler-16 system, the safe zone starts at about 0.63 astronomical units. By moving Earth to 0.39 astronomical units to keep it warm, we have placed our planet inside the gravitational danger zone. Earth's orbit would become wildly unstable. Every 41 days, the massive shifting gravity of the two stars would violently yank on our planet. It might take a few thousand years, but Earth is mathematically doomed. Eventually, the chaotic gravity will either rip Earth apart, swallow it into one of the suns, or slingshot us entirely out of the system into the freezing void of deep space. Proxima Centauri, flare star. If Proxima Centauri replaced our sun, at noon, you could look up and still see a sky full of bright stars. Somewhere in the middle of them would be a tiny, dim red disk. That would be your new sun. Proxima Centauri is a red dwarf, putting out just 0.17% of the energy of our current sun. At our current distance, within days, the oceans would freeze completely solid. Global temperatures would plummet to roughly minus 370 degrees Fahrenheit, at which point the atmosphere itself would begin to freeze. First, carbon dioxide would fall to the ground as a blizzard of dry ice. Then, the sky would literally fall, as nitrogen and oxygen condense into liquid and rain down, burying the frozen oceans under dozens of feet of alien snow. Even if you could survive that, Earth wouldn't stick around. Proxima Centauri has only 12.5% of the mass of our sun. With the sun's massive gravity suddenly replaced by Proxima's weak pull, we would rip free from the star's grip entirely, shooting out into the pitch-black void of deep space as a tumbling, frozen rogue planet. To keep Earth warm around a star this dim, we have to move it incredibly close, and in this extremely tight orbit, a single year takes about just 8 days. However, Earth would become a completely alien world. At this dangerously close distance, the red dwarf's gravity would act like a brake on Earth's spin, eventually causing it to become tidally locked. Just like our moon, Earth would only ever show one face to the star. The planet would be split in two, a permanent day side that is a boiling, scorched desert, and a permanent night side trapped in a glacial, frozen nightmare, where oceans turn to solid ice in a massive, cold trap. To survive, humanity and all agriculture would have to migrate to the Terminator line, or Twilight Zone, a narrow ring around the planet where the two sides meet. Here, the red sun would sit permanently on the horizon, casting endless, long shadows. From space, Earth would look like a giant, terrifying eyeball. However, living in the Twilight Zone wouldn't be peaceful either. It would be a life of constant terror. Proxima Centauri is a violent flare star. Because of its volatile magnetic fields, it frequently erupts, sometimes increasing its brightness by even 60 times in a matter of minutes. If you were outside and saw sudden massive auroras glowing violently in the sky, it would be a warning siren. It means a superflare has just slammed into the upper atmosphere. These flares don't just scramble GPS, they blast the planet with lethal doses of X-rays and ultraviolet radiation. Anyone caught on the surface of the dayside or the twilight zone would have minutes to dive into deep underground bunkers or heavily shielded underwater habitats, or face instant, horrific radiation sickness. Over thousands of years, these relentless flares would literally strip away the energized upper atmosphere, slowly bleeding Earth's air out into space until nothing is left. Sol, red giant. This one is particularly interesting, as it's actually the type of star our own sun will turn into in the future. If we swapped our current sun for its future red giant self, you wouldn't just see a warm orange disk. When our sun runs out of hydrogen, its core will compress, and its outer layers will balloon outward to monstrous proportions. At its peak, it will be up to 3,000 times more luminous, and its size will expand to roughly 200 to 300 times its current radius. If Earth stayed where it's at, the sky would be consumed by a huge, towering wall of orange plasma stretching across the entire horizon. The sheer radiant energy would instantly flash boil the oceans, blow away our atmosphere, and melt the continents into a glowing, rolling sea of magma. There's more to it though. Because the sun has swollen so massively, Earth would find itself skimming or entirely submerged within the star's outer atmosphere. Plowing through stellar gas would act like hitting the brakes. Earth would lose its orbital energy, resulting in a rapid, inescapable death spiral inward until the molten remains of our planet are swallowed by the star's core. This time, to survive a star 3,000 times brighter than the sun, we can't just move a little bit away. We would have to push Earth all the way out to the Kuiper Belt, past the orbit of Pluto. Only then would the temperature finally be stable. But out there, a single orbit takes over 300 Earth years. Entire generations of humans would be born, live, and die entirely within a single season. Winter would last for nearly a century. However, here's the most interesting part. In the earlier stages of the sun's red giant brightening, before it reaches its hottest peak, the habitable zone would, for a period of time, sweep across the region of Jupiter and Saturn. These planets are orbited by massive ice moons, like Europa, Enceladus, and Titan. Under the heat of the new red giant, these frozen wastelands would rapidly thaw. The miles-thick ice shells of Europa and Enceladus would melt entirely, transforming them into global tropical water worlds. While humanity huddles on Earth out near Pluto, the moons of Jupiter and Saturn would become the most prime, habitable places in the solar system, potentially even thawing out dormant alien marine life that had been trapped beneath the ice for billions of years. Vela Pulsar, neutron star. If the Vela Pulsar replaced our sun, you'd see darkness outside. Your phone speakers would start hissing with a fast click, click, click. Cameras would distort with rolling bands of static. And then, the entire horizon would ignite with a violent pale green aurora, flickering in a steady beat. You see, a pulsar is a neutron star, the crushed, dead core of an exploded supernova. It packs the mass of nearly 2 suns into a sphere about the size of a single city, and it spins wildly, sweeping out narrow beams of radiation like a cosmic lighthouse. Vela, for example, rotates exactly 11.2 times per second. If Earth stayed where it's at right now, you would be hit by an apocalyptic cosmic strobe light 11 times a second. Also, since Vela's magnetic field is billions of times stronger than our sun's, that beam would act as a relentless, repeating EMP. Within seconds, the induced currents would melt power grids, explode transformers, and permanently fry every microchip on Earth. Moreover, Vela doesn't shine with visible light. It blasts out pure, ionizing radiation. This energy is so unimaginably high that it would act like a nuclear blowtorch. As the beam hammered the planet 11 times a second, the upper atmosphere would instantly ionize into a superheated, glowing plasma. Within minutes, the radiation would strip away our ozone layer entirely and sterilize the facing hemisphere of the planet, shredding the DNA of any living thing left on the surface. Unlike the other replacements, we can't describe the scenario of what would happen if we moved Earth to the habitable zone. Since Vela emits almost no visible light or infrared heat, moving closer to get warm just means you are moving closer to a gamma-ray radiation cannon. The only reason the Earth would start to feel warm is because the lethal radiation is physically boiling the atmosphere and baking the rocks. Worse, to get that close, we would be moving dangerously near a tiny object with twice the mass of our sun, because all that mass is concentrated into a city-sized point. The gravitational difference between the front of the Earth and the back of the Earth would be insane. These extreme tidal forces would literally stretch the solid rock of our planet. Moving Earth close to Vela would trigger continuous global magnitude 10 earthquakes, ripping the planet's crust wide open and turning the surface into a fractured sea of erupting volcanoes. Earth would be ripped apart from the inside by gravity and boiled from the outside by radiation. If you want to discuss this video or suggest an idea for the next one, join my Discord, link in the description.